Happy morning, students. Welcome to Booster Fire Secondary School online classes. So now let us see about mole concept. The study of the collection of particles by using mole as the counting unit in order to express the mass and volume of such unit particles in a bulk of matter is known as mole concept. In the SI system, the mole is the amount of a substance that contains as many elementary entities, that is atoms, molecules or other particles, as there are atoms in exactly 12 grams, that is 0.012 kilogram of the carbon 12 isotopes. So, we know that atoms are the fundamental building blocks of matter, and two or more atoms of same or different elements form a molecule. But it is impossible to count the total number of atoms or molecules in a glass of water. For this, we need to understand the concept of mole. So, we are already familiar with the measuring units like decimal, liter, kilogram, and so on. In chemistry, mole is just like those measurement units. The amount of the substance that contains 6.02 into 10 power 23 particles, that is Avogadro numbers. In other words, 1 mole of any compound or element has Avogadro numbers of molecules, that is 6.023 into 10 power 23. 1 mole of any element has 6.0222 into 10 power 23 atoms. And in case of 1 mole of water molecule, so we have previously mentioned the term dozen. 1 dozen of a thing means 12 number of them. For example, 1 dozen bananas means 12 number of bananas, and 1 dozen chairs means 12 number of chairs. But the mass of 1 dozen bananas is not equal to the mass of 1 dozen chairs, though both of them indicate equal number of things. So, mass depends upon the substance we are taking into consideration. Similarly, 1 more hydrogen or 1 more nitrogen has the same Avogadro's number of particles, but different molecules. What is this? 1 mole of hydrogen or 1 mole of nitrogen has the same Avogadro's number of particles, but different molecules. For example, atomic number of hydrogen is 1 unit. So its molar mass is also 1 gram. Again, atomic mass of nitrogen is 14 units. So its molar mass is also 14 gram. Therefore, atomic mass of an element expressed in gram, that is called molar mass of that element. Already we discussed about the previous class. While in case of compounds, it is the sum of atomic mass of all elements present in that compound. Let us move on to calculation of molar mass of some elements and compounds. Already we have discussed. So this is the mole concept. The number of moles of a substance can be calculated by the various means depending on the data. That is, the first one is number of moles of molecules. So, how much the moles of molecules are present in the substance. The next one is number of moles of atoms. So, how much the moles of atoms is present in the substance. The next one is number of moles of a gas. Standard molar volume on STP. STP means that standard temperature and pressure. That is 273.15 Kelvin or 1.00 atom. STP stands for what is this? Standard temperature and pressure. The next one is number of moles of ions. How much the moles of ions is present in the substance. So these are the number of moles present in a substance. We are calculating the available data. So in this data given, how to calculate based on the data. The first one is number of moles, mass divided by atomic mass. We have to given the mass or atomic mass. We calculate the mass divided by atomic mass and mass divided by molecular mass. So we have to given the molecular mass. We have calculated the how much moles presented by the substance. The next one is number of atoms divided by Avogadro number, that is 6.023 into 10 power 23. The next one is number of molecules divided by 6.023 into 10 power 23. After the classes, how to calculate the number of moles at the future classes. The mole of atoms. 1 mole of an element contains 6.023 into 10 power 23 atoms, and this is equal to its gram atomic mass. What is this? Mole of atoms. So, for example, 1 mole of oxygen atom contains 6.023 into 10 power 23 atom of oxygen, and its gram atomic mass is 16 gram. So 6.023 into 10 power 23 is equal to what is this? 16 gram. The next one is what is this? Mole of molecules. Mole of molecules. So 1 mole of matter contains the same for the 6.023 into 10 power 23 molecules, and it is equal to its gram molecular masses. For example, 1 mole of oxygen molecule, what is contains 6.023 into 10 power 23 molecules, and its gram molecular mass is 32 gram. Mole of atoms, gram atomic mass. This is a gram molecular mass. The next one is molar volume. Molar volume. So 1 mole of any gas occupies, what is this? 22.4 liters or 22,400 milliliter. This is called the molar volume. This is called the molar volume. So 2 marks are கேட்டதுக்கு chances இருக்கு what is molar volume or define molar volume. So this is the mole concept. Next, see about person composition. The person composition of any given compound is nothing but the ratio of the amount of each element present in the compound to the total amount of individual elements present in the compound multiplied by 100. Here we measure the quantity in terms of grams of the elements present in the solutions. So, the present percent composition of any compound is an expression of its composition in terms of all the elements present. So, the significance of this composition calculation is found in the chemical analysis. So, let me understand the percent composition of oxygen and hydrogen by taking water molecules. So, mass of an element equal to mass of that element in the compound divided by molar mass of the compound. Now, molecular mass is how to measure? Two hydrogen atoms. So, 2 into 1 plus 4 atomic mass is 16. So, 2 plus 16 equal to 18 gram. So, mass of an hydrogen equal to 2 divided by 18 into 100. That is 11.11 percentage. So, mass of an oxygen, that is atomic mass is 16. 16 divided by 18 into 100, that is 88.89 percentage. So, this percentage composition is very useful to determine the empirical formula and molecular formula. Next, we have to see for one example. Find the mass percentage composition of methane, that is CH4. Molar mass of CH4, what is this? Carbon atomic mass is 12 plus hydrogen is 1. 1 into 4, 4 plus 12 plus 4 equal to 60 gram. Next, mass of the carbon. So, 12 divided by 16 into 100, that is 75 percentage. The next one is mass percentage of hydrogen. 4, because 4 is present in the methane. So, 4 divided by 16 into 100, that is 25 percentage. So, this is the percent composition of the methane. Next, let's see about Avogadro hypothesis. So, small story I will tell you. Peter and his uncle Tony planned a trip to Italy in summer. When they reached the Versailles, Peter noticed a marble statue in a public garden. Peter asked his uncle, "Whose statue is this?" His uncle answered, "He is a famous Italian scientist, Amedeo Avogadro." Peter questioned, "Why is he so popular?" His uncle answered, "He is famous in the world of science because of his Avogadro hypothesis." Peter was confused. He asked his uncle to explain to him about Avogadro hypothesis. So, let us more about Avogadro hypothesis. It states that at the same temperature and pressure, the equal volumes of all gases have the same number of molecules. So, the law states that equal volumes of all gases under similar conditions of temperature and pressure contain equal number of molecules. So, 22.4 liters of any gas at STP contains 1 mole. What is this? 6.02 into 10 power 23 atom or molecules of that gas. So, the Avogadro numbers is discovered by Joseph The Avogadro number is discovered by Joseph last in 1865. It is defined as the number of units in 1 mole of any substance. So Avogadro number is equivalent to us 6.023 into 10 power 23. The Avogadro number is denoted by n or n naught. At the same time, let's also see if there is any relation between Avogadro number and mass of molecules. So, the relation between the Avogadro number and the mass of molecules equal to number of moles equal to number of particles divided by Avogadro number. So, already we have discussed. So, the Avogadro law is represented mathematically as B proportional to N. So, B equal to constant into N. So, let us consider an reaction between the hydrogen and the chlorine to form a hydrogen chloride gas, that is H plus Cl gives 2 HCl. So, according to this law, that is Avogadro's laws, one volume of any gas is occupied by what is this n number of molecules. So, n number of molecules plus n number of molecules gives 2n molecules. If put a n equal to 1, so 1 molecule plus 1 molecule equal to 2 molecules. Suppose half molecules plus half molecules equal to 1 molecule. So 1 molecule of hydrogen fluoride gas is made up of half molecule of hydrogen and half molecule of chlorine. So next we have discussed about what is this applications of Avogadro law. Avogadro's law explains that Gay-Lussac's law. You already studied about what is a 9th standard. Okay. So this Avogadro's law is used to determination of atomicity of gases. The molecular formula. Previous class we see about what is molecular formula. So the Avogadro law, the molecular formula of gases can be derived using this law. What is this Avogadro law? So this is determines the relationship between molecular mass and vapor density. So next class we will discuss between the relationship between molecular mass and vapor density. Next, the Avogadro law helps to determine the gram molar volume of all gases. So this is the applications of what is this Avogadro law. First one is explains Gay-Lussac's law and determination of atomicity of gases, and molecular formula of gases can be derived using Avogadro laws. So molecular formula derive பண்றதுக்கு நம்ம என்ன யூஸ் பண்றோம்? Avogadro law யூஸ் பண்றோம். So next, the Avogadro laws determines the relationship between molecular mass and vapor density, and also it helps to determine the gram molar volume of all gases. So in this class we have discussed about what is mole concept and percent composition and Avogadro hypothesis. Any doubt? Ask me. Thank you, students.